there, so in this video I'm going to be teaching you how to find an unknown side length in a right angled triangle. So here in the question I've been asked to find this side length A, and it's unknown. For a triangle, it's right angled because it's got a right angle here, this angle's 90 degrees. And that means I can use trigonometry to find A. So I can use the three trigonometric functions sine, cosine and tangent, or sine, cos, tan, as they're often shortened to. Okay, now the key way that you need to use these is, why don't I just show you, for example, a hypothetical right angled triangle. I've got a right angle here, I've got an angle, I'm just going to call it theta here, and this is the side opposite, this is the side adjacent, and this is the hypotenuse, which is the side opposite the right angled triangle, which is always the longest side. The side opposite the right angle, sorry, which is always the longest side. Okay, now the key formulas for sine, cos and tan are that sine theta equals op over height, and then to just continue here, cos theta equals adjacent over height, and tan theta equals op over adjacent. And the key way to remember this is by something called SOHCAHTOA. So you've got SOHCAHTOA. Now, you can see here that what I've got is I've got a side length A that I want to find, and this is adjacent to this angle I know. Now you never use this as your angle and the sine, cosine and tan, because it doesn't help you really at all. So here because I've got an opposite side and I've got an adjacent side, I'm going to use tangent. So because of these formulas, I know that tan of 11 degrees equals opposite over adjacent, 10 over A. Now, using a bit of algebra, I can see that if I multiply both sides by A, so I get A tan 11 degrees equals 10, which then gives me that A equals 10 over tan 11. Okay, now you could see here that for change to normal, I've got my calculator here. Now, what I'm going to use it for is I'm going to use it to calculate the tangent, because these trigonometric functions, sine, cosine and tan, they're virtually impossible, if not impossible, to work out by hand, because the numbers are so long. There's so many decimal places involved. So I'm going to use my calculator, so let me switch it on. And now I've got 10 over, and I'm going to press the tan button. Your calculator will probably have something like this as well. Tan. I'm going to type in 11, with a close bracket. I'm going to get my answer. But this can't be right, because you could see that this is negative. Now, I expected this, because if you could see, might not be able to see it clearly, you can see here there's a little R, okay, That's a unit of measurement of angles. That's called radians. We're working in degrees, as you can see by the degree symbol. So top right in the numbers. So what I have to do is I'm going to have to go shift to my setup. I'm going to have to press 3 for degrees. Now this will shift to a D for degrees. Make sure your calculator is set the same way. Now all I need to do is press the equals sign, and I'll quickly get the side length of 51.4455 ... and so on. That isn't all a number, it continues going on, so you can see what I mean about them being hard to work with. Now, you may think, well, this is impossible because this side looks like 10, but that side can't be 50. However, in most maths problems like this that you'll be given, the triangles won't be drawn to scale, so you can't use a protractor to quickly get the answer. So I've got A equals 51. Now say I included a rounding in the question, so I normally round something like this to maybe 1 or 2 decimal places. So A is 51.452 D P. There we go. Now, in your code question, you may well be given a unit. Don't worry about units in these calculations. However, obviously this side length should have the same units. Say this was in meters, I would write out conclusion and say the side length A is equal to 51.45 meters to 2 decimal places. Okay, so that was how to find an unknown side length in a right angled triangle. Thank you.